My name is Elise, this is Taylor, and this is Fred, and our presentation is on size-dependent ejaculation strategies and reproductive success in the yellow dung fly, Scaphophagous stercoria. So, the main subject of the study is the yellow dung fly, Scaphophagous stercoria. This is a species of flies that is very small and primarily mates on dung and other decaying matter. The male-to-male competition system in this species in particular is different from most other competition systems in that the male mating roles can change over time. So for example, in class we went over the example of dung beetles where there are larger competitive males and small sneaker males, and these roles are determined phenotypically and at birth. In comparison, yellow dung flies' roles can change over time since their size can change over time. The male's goal is to displace as much sperm as possible when mating. This is dependent on time spent mating. In yellow dung flies and most other males across multiple species, this is dependent on their size. And so, for example, competitive males in yellow dung flies, they face much less sperm competition because they primarily mate with their mate and they can defend from other males mating. And they face much less sperm competition overall because of this. In comparison, sneaker males face sperm competition in every single one of their mating opportunities because they have to compete with larger males that have already mated with the female or will mate with the female, for example. And in this species in particular, the amount of sperm transferred is dependent on the time spent mating because the sperm transfer rate is consistent across the board for the species. And so this study works to understand the relationship between male size and ejaculate expenditure. And the two main focuses of this study are the larger competitive males and the smaller patroller males. The larger competitive males, they mate primarily on dung, and they are readily able to defend their mates from other males coming over and taking over, and thus displacing their sperm. And their matings take place on dung right before oviposition, meaning that they have a very high chance of fertilizing eggs. And because of this study hypothesizes that these males will reserve their sperm for these very specific mating opportunities and mate less in off-site places where sneaker males primarily usually mate. And these smaller patroller males they avoid male competition on dung, and they would rather mate off-site where there's much less male competition, and females, you don't have to worry about takeovers. And this study works to understand the relationship between male size, ejaculate expenditure, and the environments in which mating takes place, since competitive males prioritize dung and smaller males prioritize off-site mating sites.
Collection was done at Todd Hall at Dairy Farm in October and November of 2013. They were collected from apple pomace, and there were a range of male body sizes. The first mating took place within 60 minutes of collection with a random female on pomace, and males were frozen and females kept until egg developed. The second mating, they were transported back to the farm, and random new males taken from random dung, and mating took place from there. All progeny were raised in the lab with the females, and then all flies were frozen right after they hatch. PCR was done with the bugs because they wanted to make sure that the bugs for this test or this experiment were actually mating with the females. So PCR was taking place on the females just so that they could verify or validate that the females were actually mating with the males on site, or even if the males that were mating with the females had their chance of paternity through the PCR readings that they were getting. Statistics were taken with a multiple linear regression, copulation during as response to males in environments, and relationships between HCl and paternity.
So on the pomace, the copulation rate and the length of the male hind tibia decreased, while on the dung, the sperm number and the length of the hind tibia increased. This is significant because there is a direct correlation between the hind tibia length and sperm number and copulation. Smaller males and larger males had reversed results. So smaller males mated for longer on pumice and transferred more sperm as a result, which meant that they fathered more young on pumice than they did on the dung. However, larger males had shorter copulation times on pumice than dung, so they transferred less sperm on that substrate, and they fathered more young on the dung than they did the pumice. However, overall, larger males still fathered more young on both substrates, and dung matings had 3 times more offspring on average. The results were as expected. There was a 71% success rate of fertilization on average on the dung compared to 23% success rate on the pumice. Reproductive investment was reversed in small males, meaning that they prioritized the pumice more than the dung. This is probably because of risk of takeover. So if they spent longer mating on the dung, they would not be able to defend themselves if a larger male were to take over because they're just too small. So that would mean that their mating got interrupted and their chances of paternity were significantly decreased. This study did not take variation of female behavior into account, so cryptic female choice, which would naturally occur, and it also didn't take into account the risk of takeover that naturally occurs. More work needs to be done to determine why copulation is slower without dung than with the dung. It probably has to do with female quality because the quality of females is lower on apple pumice, or diet quality because the males might only go to apple pumice when they need to feed. And then smaller males are essentially just making the best of a bad situation. Either way, the larger males father more young than the smaller males, so the smaller males have basically just developed a strategy to increase their chances of paternity, but they're still not winning. Our discussion question is, what are some potential reasons why copulation might be slower without the presence of dung?